Good morning to all. I am Jeeva, working as an assistant professor of EC department at SRM Madurai College for Engineering and Technology. In this lecture video, I am going to discuss about the analysis of resistors in series and parallel circuit. The resistor is nothing but an electronic component that will oppose the flow of current. In this presentation, we'll explore the resistors are connected in series and parallel configuration. So, the main function of the resistor is opposes the flow of current, and it also used to regulate voltage and current levels within the circuit. So, the resistance is measured in ohms and it is represented by the symbol ohm. This is the symbol of the resistors R, and the flow of current in the resistor is I of t, and the voltage drop across the resistor is known as V of t. The factors affecting the resistance are of the materials are length, cross section, and resistivity. So the resistance of each material is written as R is equal to rho L by A into O. It also depends upon the temperature. If the voltage and current are in direct current means by using Ohm's law, V is equal to I into R and I is equal to V by R. From the relation, we have to calculate the power. So P is equal to V into I. If suppose the resistors are contained in series, a series circuit is one in which the several resistors are connected one after other. So in this circuit, the resistors R1, R2, and R3 are connected in series, and the supply voltage is known as V voltage. So for series circuit, the current will be the same and the voltage will be varied. So here V1, V2 and V3 with the voltages across the terminals resistance of R1, R2 and R3. So the voltage drop across the each resistor is equal to V1 plus V2 plus V3. By using this relation, we have to calculate the equivalent resistance. For example, we have to take one series circuit. Here the R1, R2 and R3s are connected in series manner. So here V is equal to I into R. So V1 is equal to voltage drop across R1. So V1 equal to I into R1, V2 is equal to I into R2, and V3 is equal to I into R3. Then substitute in this relation. So I into R equivalent equal to I into R1 plus I into R2 plus I into R3. So here the current will be same. So take it outside. I into R1 plus R2 plus R3. I into R equivalent. So from this R equivalent is equal to R1 plus R2 plus R3. So suppose the resistors are connected in series means the total equivalent resistance is equal to so the sum of the individual resistance. So in this relation is for n, suppose the resistors are n number of resistors are contained in series means the R equal to R1 plus R2 plus R3 up to Rn. These are the some characteristics of the series circuit. The same current will be through the flows through the each resistance. The supply voltage V is the sum of the individual voltages. V is equal to V1 plus V2 plus V3. The equal resistance is equal to the sum of the individual resistance, and the equal resistance is the largest of all the individual. For example, the equal resistance R equivalent is greater than R1 and R2 and R3. If suppose the resistors in connected in parallel. The parallel circuit is one in which the several resistors are connected across one another. So here the three resistors R1, R2 and R3 resistors are connected in parallel, and the supply voltage is V, and the current I1, I2 and I3 with the current flow through the resistance R1, R2 and R3. So I1 current is flow in the R1 resistor, the I2 current flow in R2 direction, and I3 is the current flow in R3 resistor. So the total current in the parallel circuit is I equal to I1 plus I2 plus I3. By using this relation, we have to calculate the R equivalent of a parallel circuit. So here we take one parallel circuit. The relation I equal to I1 plus I2 plus I3. By using the Ohm's law, I equal to V by R. So here a total current I is equal to V by R equivalent. I1 is equal to V by R R1, I2 equal to V by R2, and I3 is equal to V by R3. So substitute in this equation. So V by R equivalent equal to V by R1 plus V by R2 plus V by R3. Here the voltage will be same. So we have to take it outside. V into 1 by R1 plus 1 by R2 plus 1 by R3. So the common term cancel out. So 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3. Similarly, we have to connect n number of contacts are connected in C parallel means at that time the total resistance equivalent resistance is written as 1 by R equal to 1 by R1 plus 1 by R2 1 by Rn. So these are the characteristics of parallel circuit. The same potential difference lives across all the resistance. The total current is always sum of all the individuals. So I is equal to I1 plus I2 up to In. The reciprocal of the equal resistance of a parallel circuit is equal to the sum of the reciprocal of the individual. So 1 by R equal to 1 by R1 plus 1 by R. And also the equal distance is the smallest of all the individual distance. R equal is less than R1 less than R2 like that. And the equivalent conductance is the arithmetic addition of the individual conductances. Here a simple problem. So find out the equivalent distance between A and B are shown in figure. So here the 1 ohm resistor and 1 ohm resistor is connected in parallel and it will be connected in series. So first we have to calculate the 1 ohm resistor connected with 1 ohm resistor. So already we know that if suppose the resistors are connected in parallel means 1 by R equivalent is equal to 1 by R1 plus 1 by R2. Here R1 value is 1 ohm and R2 value equal to 1 ohm. So substitute in this 1 by R equivalent. First we have to take the LCM. So R1 R2, here R1 plus R2. So R equivalent is equal to R1 R2 divided by R1 plus R2. Substitute the R1 R2 value. So 1 into 1 divided by 1 plus 1. So 0.5 ohm. Now this 0.5 ohm is connected in series with this 0.5 ohm. So we have to redraw the circuit. 0.5 ohm connected with 0.5 ohm in series and connected in parallel with this 1 ohm resistor. So here 0.5 ohm and 0.5 ohm is connected in series. So R equivalent is equal to 0.5 plus zero point 0.5 is equal to 1 ohm. Now this 1 ohm resistor is connected in parallel with the 1 ohm resistor. In the terminals A and B, 1 ohm parallel with 1 ohm. So by using R equivalent relation, R equivalent is equal to 1 into 1 divided by 1 plus 1, so 0.5 ohm. So in this circuit, the equivalent resistance between A and B is 0.5 ohm. Similarly, we have to calculate the parallel and series equivalent resistance by using the formula. Thank you.